All right, do you like my thumb? Hello, chubby little thumb, looking at you. All right, so here's how questions could be asked. I'm going to have two examples, and here's how a question could be asked. You want to know, is that function continuous at a particular x value? Okay, and you have to remember what piecewise functions look like, how you define them. Okay, so this basically says I've broken up the domain, in this case, into three regions. The part on the domain that are less than 3, greater than 3, and exactly equal to 3. And here's the y values for the three different portions. Okay, we're not going to graph it or anything, but my whole function is defined in three pieces, a piecewise function. Okay, so stop the video and take these notes. Okay, so I have to satisfy the three conditions of the definition. Here's satisfying step number 1. See if you have any questions for me. I figured out if I plug in 3, I get out 8. Make sure you understand which of these pieces I used. Okay, and stop the video and take those notes. Okay, so this whole thing, number 2 actually number 2 ends down here. I want to see if the limit, if I intend to go to a particular value from both sides of 3. Notice I have to do from the left side of 3. Please take some time to understand how I'm writing this. This is how I expect you to write it and how it's mathematically correct. The limit is equal to just carrying the limit through here. Notice which piece I use. I use that piece since I'm coming from the left. Coming from the left are values less than 3, so I have to use that piece. And then here's coming from the right. How do I know that? Think back to pre-cal with that plus sign. Why do I use that piece? Well, coming from the right are values bigger than 3, so I have to use that piece. So confirm for yourself that yes, the limit from the left is 8, the limit from the right is 8, and so forth. Therefore, the whole limit is 8. Okay, so I've satisfied the second part of it. And then the last part is just wrapping up. Does the limit equal the value? In this case, it does, so my function is continuous at 3. I reach 8. My limit intends to go to 8. Everything's good. All right, that's one example. Here's a little trickier example. Let me turn my page. All right, so stop the video and take those notes. All right, so they might ask you, let's combine a little algebra and a little detective work with our calculus knowledge. So again, a piecewise function. Again, in this case, in 3 pieces, regions of the domain less than 2, greater than 2, and equal to 2. But now I have 2 variables. And the question is, can you find the appropriate variables, fill those in with numbers, so that I'm continuous at 2? Okay? Again, you have to work through the definition, and this time you're going to use systems to solve it. You have 2 unknowns, so you have to have at least 2 equations. Yeah? Stop the video and take those notes. All right, so I'm going to put it on you. The more you think about your notes and the more you ask me questions and struggle with it, the more it makes sense. I've written it out here. It's a matter of going through the steps and seeing what has to equal to each other and then solving for variables when I can. If you have questions, ask me in class. See you next time.